Thank you very much, Rita, and thank you for the organisers for inviting me here to Madeira. I worried on Monday whether I would arrive or not, because as my plane was approaching Funchal airport, it aborted the landing, and we circled around the Madeira Islands while I was worried about whether we had enough fuel. And eventually we made it down, and the plane landed very assertively, and I was glad to be on this small rock in the middle of the Atlantic. So what I want to do today is to talk about some work I've been doing over the last 5 or 6 years with my collaborators and research students on developing techniques for analyzing the time evolution of network representations of data. And so last night, Linda reminded me that I started looking at graph structures a long time ago, back in the early 1990s, and she reminded me her kindness as a reviewer, since all my papers went to her for review at that time. And I started studying this subject by taking her work and seeing whether we could make it inexact by adding the concept of probability to it. And so I've continued working on networks ever since, and this topic has acquired some interest in the field of complex networks. And really what I'm doing is moving from pattern recognition to complex networks, trying to import some of the techniques that we developed. And in particular, what this talk is about is developing a characterization of networks based on their entropy, and seeing whether we can use that both for complexity level analysis of very large networks describing big data sets, and whether we can use ideas imported from physics, I'm sorry about that, in order to try to understand how networks evolve with time and how anomalous behavior develops in networks. So these are the people that I've done this work with: Lin Han, Francesco Escalano, Cheng Yi, Jianjia Wang, Giorgio Minello, Andrea Torsello, and Richard Wilson, my long-term collaborator. So the idea is this: networks are now common representations of all sorts of complex data sets, and they have really brought about the development of a field known as complex systems, where the idea is to use a network to describe a system which we can't simply describe by other means. And so really we're looking at, sort of, if you want, many-body systems, where the interactions between the bodies composing those systems are very complicated, and we seek succinct representations of those network representations as a way of understanding